Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 6G assignment. Okay, first one is number 1 here. Locate the turning point or vertex for each of the following quadratics. In each case, state whether the vertex is a minimum turning point or a maximum or minimum. Okay, so just so that you know, or remember, turning point and vertex mean the same thing. Okay. So if I were you, I would do x equals negative b over 2a, and that's going to help us find the x-coordinate of the vertex. And then once we know the x-coordinate, plug it back in and find the y-coordinate. Okay? So let's see. A is 1, and b is negative 4. So we've got, for a, we're going to get x equals negative 4 all over 2 times a, which is 1. So we get x equals 4 over 2. So the x, that was weird. There we go. The axis of symmetry is going to be x equals 2. Okay. So if we are looking for the turning point or vertex, we know that for a, we've got x is 2. And now to figure out what the y is, we will simply plug in 2 into this original equation to figure out what the y is. So y equals 2 squared minus 4 times 2 plus 2. So we get y equals 4 minus 8 plus 2. Let's see, that's going to give us y equals negative 2. So we get 2 and negative 2, and since it is positive, that means that this graph opens up, so it will have a minimum. So 2, negative 2, and the vertex is a minimum turning point officially. Okay, there we go. All right, for E, same idea, except for the problem is we don't know what the we don't know what the A or the B is. So you could FOIL this out and find out what the A and the B is, or I'm going to just find the axes intercepts. I'm going to find the x-intercepts for both of those. And then I will just split the difference, find the middle of that, and that will tell me what my x-coordinate is. So I know that my x-intercepts are going to have to equal 4 and negative 2. So to find exactly halfway between that, that's kind of like a little midpoint there, right? Halfway between 4 and negative 2, we would just do 4 plus negative 2 over 2. And that is going to give us 2 over 2, which is 1. So we know that the x-coordinate is going to be 1. And then to find the y-coordinate, I don't know why I did it over here. I should have done this all over here. Sorry. To find our y-coordinate, we're just going to plug the 1 into the original. So that's going to be y equals 1 minus 4 times 1 plus 2. Okay. So we get y equals negative 3 times positive 3, right? So y is going to equal 9, negative 9, excuse me. So we get 1 and negative 9 is our vertex. And this is also positive, so this also opens up. So this will also have the vertex will be a minimum turning point. Okay? Okay. Let's look at the next one. Number 2, for each of the following quadratics, find the axes intercepts, coordinates of the vertex. Axis of symmetry, sketch it, and state the domain and range. Okay, so it looks like a lot, but it'll all kind of work together here. Okay, so find the axes intercepts. X intercepts on this one here has to be 1 and 7, right? Because 1 minus 1 is 0, and 7 minus 7 is 0. So we've got 1 and 7. So this is A. Let's see. The y-intercept is when these equal 0. So that's going to be 0 minus 1. So let's do this. Y-intercept is going to be 0 minus 1 and 0 minus 7. So the y-intercept in this case is going to equal, or be, positive 7. Okay? So we found the axes-intercepts. Now, find the axis of symmetry. We could do x equals negative b over 2a. Or what we can do instead is just find the halfway point between this 1 and 7, right? So we could do 1 plus 7 over 2. That's going to be 8 over 2, which is 4. So our axis of symmetry is going to be at x equals 4 for part I. X equals 4. And then here's our, here's our two intercepts. X-intercepts and Y-intercepts. Okay? Axis of symmetry is at 4, so we can draw, if we want to, nice little dotted line there. Find the coordinates of the vertex. So look, we got the x-coordinate. Now we can plug that 4 in for the x and find the y. So for I, we're going to get y equals 4 minus 1 times 4 minus 7. So in this case, we're going to get 3 times negative 3, right? So the y in this case is going to equal negative 9. So our vertex is going to be 4 and negative 9. 4 and negative 9 right there. Okay, which looks about right because it's going to go up like this and up like that, right? So we've done 1, 2, and 3. Sketch the quadratic. Look, we have enough info to make ourselves a sketch here. Forgive my not so straight lines, but you get the idea. Okay, so we have now sketched the quadratic. And let's see, last thing is state domain and range. So let's see, V on this one. Oh, sorry, just plain old V. State the domain and range. Domain, what can the x's be? X's can be forever small or forever big. So domain on all of these are going to be real numbers. And then the range, the lowest it ever gets is here at negative 9. So I'm going to do y and negative 9. And y is getting bigger and bigger and bigger. So y has to be greater than or equal to negative 9. And there's our domain and range for that one. Okay? All right, and then let's look at G here. I'm going to go back and erase this stuff here first so that we've got more room to see what's going on here. Okay. For G, let's see, axes, intercepts. So now, if we do that, this one's going to be a tougher one to factor. Okay, so maybe let's do this. Let's find the axis of symmetry first. Okay, so we're going to do part double I first here. So that's going to be x equals negative b over 2a, right? So this is going to be x equals a is 2, b is negative 5, right? So x equals negative 5 all over 2 times 2. So that's going to give us 5/4 is our x for the axis of symmetry. Okay, so 5/4 is about right here ish, just past 1, right? Okay. Then let's see, I guess we can find the y coordinate of the vertex, right? We're still going to have to go back and find the axes intercepts, but this is going to give us a decent idea what this thing's going to look like. So let's see, 1, 2, I. Part 3, find the coordinates of the vertex. So we are going to do y equals 2 times 5/4 squared minus 5 times 5/4 plus 2. Okay. That one is not a very nice one, so let's use our calculator for that. Okay, here's this whole thing entered in. We push enter, negative 1.125. So nice, isn't it? Okay, so that gives us our vertex to be 5/4, which is 1.25, and negative 1.125, which is negative 9/8. Okay, let's see. So that is this 1.125 and negative 1.125. So that's about right there is our vertex. We still probably need to go back and find the axes intercepts as well. So that's going to be part I here. So if we're looking for the x-intercept, that's when y equals 0, right? So we get 0 equals 2x squared minus 5x plus 2. Okay? Okay, so we're going to want to factor this thing out because we cannot factor a 2 out of all of these here. So our leading coefficient is something other than 1. So here's how I like to do this one. I'm going to multiply the first number by the last number. 2 times 2 gives me 4. So I now know I got to come up with the factors of 4, 1 and 4, or 2 and 2. And these factors have to add up to negative 5. So 1 and 4 add up to negative 5. So what I'm going to do is I'm going to rewrite this thing over here, and we get 0 equals, we're going to leave the 2x squared just like it is, and the plus 2. So this part and this part stay the same. We're going to rewrite the negative 5x as a 1x and a 4x. And in order for these to add together to get negative 5, they're going to have to both be negative. Okay, it doesn't matter which one you put where. And then you simply put parentheses around the first two terms and the last two terms and put a plus in between those. And now factor each set of terms. Okay, this is called factor by grouping. Okay, so I can factor an x out of both of these, and when I factor an x out of that, I'm left with 2x. Factor an x out of that, I'm left with negative 1. And on this one here, whenever I have a negative out in front here, I always want to factor that negative out. And then a 4 and a 2, I can get a 2 out of both of those. I'm going to factor a negative 2 out of both of those. Negative 4x divided by negative 2 is 2x, and positive 2 divided by negative 2 is negative 1. Okay, now these two things should match, and they do, so that's good. That means our two factors are going to be 0 equals whatever these two matching ones are, which is 2x minus 1, and then also the leftovers, x minus 2. Okay, oops. X minus 2. Those are the two factors. Officially, what we're doing is we're actually factoring a 2x minus 1, because this is a term and this is a term. We're officially factoring a 2x minus 1 out of both of those. And once we do that, we're left with x minus 2. That's why we have the 2x minus 1 that we factored out and the x minus 2. Okay, so then from there, we got to set those equal to 0. So, so x intercepts are going to be at, take the opposite of the 1, positive 1, divide it by whatever's in front of the x, 1/2, and the 2 minus 2 is 0. So there's our two x-intercepts. Okay, that was kind of a doozy, but that's all right. That's going to help us figure this out. So we got 1/2 and at 2. Yeah, I actually put that over there at 3. That's why that looks so funny. Let's undo that. There we go. And it should actually be over here at 2. So that looks pretty decent. Okay. And then we'll also want to find our y-intercept as well. So y-intercept is when the x's are equal to 0, right? So y equals 2 times 0 squared minus 5 times 0 plus 2. Those both turn into 0. So the y-intercept is just going to be this 2 right here. Okay. Which follows along with that. And now we can sketch our quadratic like so. And then the domain and range, so V. Sorry, this is all kind of out of place. This is supposed to be up here with this stuff here. Okay, so domain and range. So domain is what the x's can be. So for this, the x's can get forever and ever small and forever and ever big, all real numbers. And then the range, the lowest this ever gets is at negative 1. And then this is for y, because the range is the y's. And then it gets just bigger. It gets bigger and bigger from there. So y has got to be greater than or equal to negative 1. And there's our domain and range. Okay. All right. Last one to take a look at, number 3 here. Find the minimum value of this and the maximum value of that. So y equals x squared is a positive graph. So we're looking for this right here. Okay. So let's plug this thing into x equals negative b over 2a, right? So our a is 1 and our b is negative 8. So in this case, we get x equals negative 8 all over 2 times 1. So that turns into 8 halves, or x equals 4. Okay, and now to find the y value, we'll want to plug in our 4 into that x, right? So then we will take y equals 4 squared minus 8 times 4 plus 5. So y equals 16 minus 32 plus 5. That's 21 minus 32. So that looks like y equals negative 11. So our minimum value is negative 11, and that's when x equals 4. So really the minimum value for a, where are we going to write this? Right here. Minimum value, y equals negative 11 when x is 4. Because really this is our minimum value, right? When we're talking about minimum value, that's our y. Okay. Okay. For b, we'll do the same thing, right? A is negative 1 and b is negative 10. And we'll plug that into x equals negative b over 2a. So x equals negative 10 all over 2 times a, which is negative 1. So that is 10 over negative 2, which gives us negative 5 for the x. Okay, now we plug that 5 in for the x's and see what we get for y, right? Y equals negative, and then negative 5 squared minus 10 times negative 5 plus 4. So negative 5 squared is 25, and then the opposite of that is negative 25. Negative 10 times negative 5 is plus 50, and plus 4. So that's going to be y equals 29. So y equals 29 when x equals negative 5. Okay? Okay, that's all we have for these problems here from 6G. If you have any further questions, please feel free to ask. Thanks.